Okay, let's dive into this explainer. Somewhere in India right now, a train is doing something that would have been completely impossible just a few years ago. Think about this. It's carrying shipping containers stacked 2 levels high, running directly under live overhead electrified wires, and it's hitting speeds close to 100 kilometers an hour. I mean, this isn't your standard railway line. What we're looking at is a glimpse into India's 7,000-kilometer freight future. Today, we're going to see exactly how India is engineering one of the most technically advanced pieces of infrastructure in the world right now.
To really appreciate where we're going, we first have to understand the massive bottleneck of the past. Historically, India's railway problem boiled down to one thing: shared tracks. Freight trains carrying vital coal or consumer goods were constantly sharing lines with passenger expresses. And you know how it goes. Passenger trains almost always get priority at the signals, so freight usually loses that fight. Cargo would move dead slow across the country, often averaging under 25 to 35 kilometers per hour. The solution? Well, it's straightforward but absolutely massive in scale. Take the freight trains, put them on their own separate, double-stacked, electrified tracks, and let them cruise at 100 kilometers an hour without ever having to yield to a passenger train.
That concept brings us to our core definition for this explainer: the Dedicated Freight Corridor, or DFC. It is exactly what it sounds like: a purpose-built, double-line, electrified heavy-haul rail network used exclusively for freight cargo. To make this massive leap in infrastructure a reality, India actually set up a specific agency back in 2006 called the Dedicated Freight Corridor Corporation of India, or DFCCIL. Their entire mission? To plan, build, and maintain this entirely new parallel rail universe.
Now, what's really interesting about this is Section 1, the holy trinity of freight: weight, height, and speed.
You see, these new corridors aren't just regular tracks without passenger trains. They are fundamentally engineered differently right from the ground up to maximize 3 specific metrics. Let's break down the first pillar: weight. A standard Indian Railways track is built to handle a 25-ton axle load. But the DFC tracks? They're engineered for a massive 32.5-ton axle load. That requires heavier rails and weight-denser sleepers to carry the extra weight safely. And because the tracks are this incredibly strong, trains on the corridor can run up to 1.5 kilometers long. That's roughly double the length of a normal Indian freight train. Heavier loads and longer trains mean dramatically more cargo moved every single trip. Moving on to the second engineering pillar: height. The DFC features a much taller structure gauge, providing up to 7.1 meters of overhead clearance. That is a huge leap from a conventional line, and it's exactly what allows containers to be stacked 2 levels high. But what makes this truly incredible is that on the Western corridor, this double stacking happens entirely under a live 2 by 25 kilovolt AC catenary wire. India built this clearance in from the very start, which makes the Western route the first double-stacked electrified freight corridor of its kind anywhere in the world. Literally nowhere else is doing this.
And finally, the third pillar: speed. Because you don't just want heavy and tall trains, you want them moving fast. Freight on these corridors reaches top speeds of 100 kilometers per hour. To pull that off, they're using some of the most powerful freight locomotives on the planet, like the 12,000 horsepower WAG-12, which was developed in partnership with Alstom. And to keep these massive, fast-moving trains safe when they're running just 5 minutes apart, the network uses automatic block signaling backed by Kavach, which is India's own homegrown automatic train protection system.
Section 2. East meets West. India's twin corridors. So, we have these incredibly advanced heavy-haul trains, but where exactly are they running? Well, the 2 active routes serve very different economic purposes. The Eastern DFC, running 1,337 kilometers from Punjab down through to West Bengal, is all about heavy domestic fuel. It was largely funded by a major World Bank loan and built primarily to move massive volumes of coal from eastern mines directly to northern power plants. Meanwhile, the Western DFC is a 1,506-kilometer stretch from near Delhi all the way down to Mumbai. Funded heavily by the Japan International Cooperation Agency, or JICA, this route is entirely export-driven. It connects northern India's industrial heartland straight to Jawaharlal Nehru Port, or JNPT, which happens to be India's busiest container gateway. To truly grasp the impact of this infrastructure, we really have to look at the immediate, real-world efficiency it delivers. Take the Eastern route as a prime example. Before the DFC, a coal shipment from the eastern mines to northern power plants would take roughly 35 hours of transit time. Today, that exact same trip on the dedicated corridor takes just 20 hours. I mean, that is a massive operational leap for the supply chain. And as of a highly successful final trial run on March 31, 2026,
which officially link the final stretch into JNPT, both of these massive regional corridors are fully commissioned end-to-end. That brings the combined operational track length to 2,843 kilometers. And what's really staggering is the price tag. The total project cost came in at roughly 80,000 to 90,000 crore rupees. When you compare that to the cost of other mega projects like expressways or bullet trains, it is a remarkably cost-effective investment for a network that essentially touches the entire country's freight traffic.
So, the crucial point is, Section 3, the macro impact, transforming the economy.
It's all about how this physical infrastructure actually ripples out to transform the broader Indian economy. It's not just about the trains themselves, it's about the domino effect these corridors create across the nation's logistics and transport networks. Think about this. A single coal-hauling train on the Eastern DFC, roughly 1 kilometer long, removes the equivalent of about 72 trucks from the national highways. And the double-stacked container trains on the Western route displace a proportionally larger volume of truck traffic per trip. Multiply that across hundreds of trains a day, and you are drastically decongesting India's roads. But here's the brilliantly interconnected part. By pulling all these massive, slow freight trains off the old conventional tracks, it directly frees up space for passenger travel. With the freight out of the way, semi-high-speed passenger services like the Vande Bharat and Gatiman Express can run faster, more punctually, and with much higher frequency on the old network.
Then there is the simple, undeniable economics of the whole thing. When we look at transport cost per ton kilometer, moving freight by road costs roughly 3.78 rupees. Moving it by rail on the DFC, that drops the cost to just 1.96 rupees. Every single ton of cargo that shifts from the highway to the dedicated corridor is moving at nearly half the price. It's a total game changer.
But who is actually running these cheaper, faster trains? It's important to clarify that DFCIL only maintains the physical tracks. The actual trains are run by a mix of operators in a highly competitive market. The state-owned Container Corporation of India, CONCOR, holds a majority 67% share, but the remaining 33% is made up of private players like Adani Logistics and Hindem Terminals. They operate by plugging into these massive, multimodal logistics parks built alongside the corridor. This setup allows exporters to seamlessly transfer cargo straight from a road truck, right through a warehouse, and directly onto a double-stacked DFC train.
When you combine the cheaper rail transport, the super-efficient logistics parks, and the decongested highways, you arrive at this ultimate macro metric. Historically, India's logistics costs hovered around a very high 13 to 15% of GDP. Today, that number has plummeted to roughly 8 to 9%. In fact, the World Bank estimates that just the Eastern Corridor alone has already saved India around $58 million in logistics costs. That is real money staying in the economy.
Let's move to and see how this builds. Section 4, a 7,000-kilometer future, the next generation.
This massive drop in costs and the huge boost in efficiency is exactly why the project isn't stopping here. India actually has an active pipeline of upcoming routes representing roughly 2 lakh crore rupees in future investment. The big headline project, which was fast-tracked in the 2026-27 union budget, is the Dankuni-Surat corridor. This 2,100-kilometer route is absolutely vital because it will finally stitch the existing eastern and western spines together into one continuous loop from West Bengal all the way over to Gujarat. And alongside that, 3 more routes are in advanced planning: an 1,100-kilometer East Coast corridor, a 975-kilometer north-south sub-corridor right through central India, and a smaller 195-kilometer east-west spur serving mineral-rich zones.
When you tally all of those planned expansions up, you get this climactic number. The current operational network of just under 3,000 kilometers is firmly on track to more than double in size. India is aggressively building toward a fully interconnected, dedicated freight network spanning well over 7,000 kilometers in total length.
Which leaves us with this massive, big-picture thought to wrap things up. By cutting transport times in half, slashing logistics costs, and linking domestic resources directly to high-speed export ports, this isn't just about trains anymore. It's about fundamentally rewiring an entire economy. With India's 7,000-kilometer freight future firmly in place, how will this new, incredibly efficient logistics foundation reposition the nation as a dominant force in the global manufacturing supply chain? It is a fascinating question, and one we are definitely going to be watching closely as this entire network continues to expand.